Listen closely to the steady, low hum of an electric fan operating in the corner of your room. It is a familiar, unassuming background sound, a soft, rhythmic displacement of air that you register without a second thought. Yet that minor, comforting breeze depends on a monumental planetary engine. The constant rotation of the Earth beneath our feet churns the atmosphere, driving global trade winds, redistributing equatorial heat, and generating the predictable weather patterns that make human life possible. Deprive the planet of that steady spin, and the atmospheric hum you take for granted dissolves into something unrecognizable. Air ceases to circulate as a gentle, life-giving rhythm, becoming a volatile instrument of pure physics. When most people picture the Earth coming to a halt, intuition paints a cinematic catastrophe, a sudden, violent slam of planetary brakes that flings oceans across continents and hurls cities into space like loose gravel. But if this deceleration unfolds gradually across a deliberate 5-year window, the physics of inertia tell a very different story. The atmosphere and oceans adjust to the dwindling rotational speed without an immediate mechanical tearing of the crust. Instead, the true nightmare is far more insidious. As the spin grinds to its final standstill, the fundamental cycle of day and night permanently breaks. One exact half of our planet becomes baked under an eternal, blinding noon, confirming the grim reality that one side of Earth never sees night again, while the opposite hemisphere plunges into an infinite, sunless freeze. To understand what remains of human civilization when the sky stops moving, we will examine this shifting planet through the eyes of specific communities forced to adapt across its radical new frontiers. Inside an underground concrete bunker in the volcanic highlands of Iceland, the air smells heavily of sulfur and hot iron, vibrating with the deafening hiss of high-pressure geothermal steam. As the Earth's slowdown reaches its 3rd year, conventional energy grids across the planet have completely collapsed. Equatorial solar arrays have melted under unyielding radiation, while continental hydroelectric dams lie frozen solid. In Iceland, survival hinges entirely on desperate technological improvisation. Engineers race against the encroaching frost to tap directly into volcanic fissures, constructing subterranean microgrids that pump superheated steam into hydroponic vaults carved deep out of basalt rock. Above ground, a desolate sheet of permanent ice creeps across the landscape, but far below, artificial lamps nourish engineered crops. An infrastructure engineer wipes grease from his forehead and checks a digital pressure gauge. A single green indicator light flickering steadily, confirming that geothermal heat is still flowing. In the remote steppes of Mongolia, every 8 hours, the heavy toll of a brass bell echoes across a frozen grassland resting in perpetual low-slung twilight. For 11 straight months, the sun has remained frozen just above the southern horizon, casting long, unmoving shadows. Without a setting sun to mark time, human psychology undergoes a terrifying breakdown. Circadian rhythms shatter, severe insomnia breeds paranoia, and the social fabric of her community unravels. To prevent total psychological collapse, a community leader establishes a rigid, artificial day-night rhythm enforced by a central clock tower. When the brass bell tolls, all village lighting is extinguished, forcing families to retreat into their insulated yurts, regardless of the bright sky outside. She pulls a thick wool drape tightly across her window, blocking out the eternal dusk to convince her mind that the day has finally ended. Absorbing the weight of these shifting human realities can be sobering, showing us just how fragile our daily existence truly is. If you are finding value in this deep exploration into hypothetical physics, take a quick moment to subscribe to the channel. Your support allows us to continue producing these immersive documentary essays. Now, let us turn to the extreme weather corridors where humanity's final migration takes place. Along the coastal wilderness of Patagonia, inside the cabin of a paramedic's heavily armored tracked ambulance, the sound is an unyielding roar, a relentless barrage of gravel and salt, scouring the steel hull at 200 miles per hour. He operates along the Twilight Zone, the narrow storm-battered ribbon of land, separating the scorched day side from the frozen night side. Because the temperature differential between the two hemispheres is staggering, the atmosphere generates a violent belt of supersonic winds along this border. His daily mission is to rescue refugee convoys migrating from the freezing dark hemisphere toward the narrow habitable zone. Through his dust-caked windshield, he watches a line of converted transport vehicles push through the gale, their high-beam headlights cutting through a dense wall of airborne sand. In a highland outpost in Papua New Guinea, a former astronomer sits on a limestone ridge, squinting through dark goggles at a horizon where the ocean has receded, miles from its original coastline. Positioned near the center of the dayside hemisphere, his home exists under a blinding sun pinned permanently overhead. The brutal heat has bleached the surrounding coral reefs white and forced marine life into deep oceanic trenches. Stripped of the changing night sky that defined his life's work, he no longer tracks celestial movements. No star can pierce the glare of perpetual noon. Instead, he devotes his remaining days to a quiet ritual, logging microshifts in atmospheric pressure with a barometer. He records his observations in a leather-bound journal, leaving the notebook open on a stone, watching the black ink dry instantly under the unyielding solar rays. The narrow twilight corridor where humanity gathers operates on a thermal principle familiar to aerospace engineering. It functions almost identically to the passive thermal management systems engineered for deep space satellites. On a spacecraft exposed to raw sunlight on one side and the absolute zero of deep space on the other, thermal fluid must be continuously circulated from the hot shield to the cold radiator to prevent structural collapse. On a non-rotating Earth, the global atmosphere becomes that fluid heat pipe, violently transferring equatorial air toward the frozen dark side, maintaining a delicate Goldilocks zone along the razor-thin boundary. While an Earth that stops turning feels like an unthinkable science fiction nightmare, astrophysicists know that this condition is actually the baseline reality for the vast majority of potentially habitable planets in the cosmos. Most Earth-sized worlds discovered in alien solar systems orbit close to small red dwarf stars. Over millions of years, gravitational forces lock these planets into tidal synchronization and forcing them to face their host star with one side forever, while the other stares endlessly into deep space. The harrowing 5-year transition we have just explored is not a real prediction for Earth. Rather, it is a scientific mirror reflecting existing alien worlds. Somewhere across the galaxy, extraterrestrial life may right now be clinging to existence along similar storm-swept twilight rings, huddled under a sun that never sets. Listen once more to the quiet hum of that electric fan turning in your room. That gentle breeze is a quiet, profound reminder of a planet spinning effortlessly through the void, maintaining the delicate balance between day and night. It is a comforting, rhythmic pulse, and a subtle reminder of the vast, complex mechanics holding our world together.